This call is now being recorded.
Right. So, yeah, that's pretty much it, right? Simple rules vectors. There are 1D vectors, there are 2D vectors. If you have a 1D vector, it means it's a vector that's either going along the X or along the Y direction. There are multiple directions that you would get along the X or Y. Multiple directions of the same thing, basically. Like north, south, which means up or down. West, east, which means left or right, okay? They can use the terms interchangeably. It depends on whoever was setting that question. Right, so now, for 2D vectors though, you will always specify direction with just the angle. Right, remember we covered the 3 different ways in which you can do this angle thing. Where it's either you measure it from a specific axis, or you use the bearing method, or I forgot the last one, but yeah, the last one was what? Let's go check because I'm using the same slides, if I can call them slides. By the way, if you guys want these, I can send them to you. I don't recall sending these to you. Oh yeah, using cardinal points where you say north of east, west of south, and so on. I usually don't like this one of cardinal points because you are likely to forget what follows what. So just use either the bearing or this one of measuring it from a reference axis. Okay, so yeah, that's it. And then there's also vectors are basically divided into the ones that are either at equilibrium or where there's just multiple forces and you have to find the resultant force, which is non-zero. When it's non-zero, those things are not at equilibrium. When it is zero, those things are at equilibrium. By things, I mean vectors or forces or whatever vectors you are considering there. Right, so let's try this one. We are asked to define a vector. This is like a grade 10 question. So what's a vector, guys? Just unmute and tell me. This is a free 2 marks. Show us how you will get this free 2 marks there. Vector. Yeah, this is where your participation starts. Gift, you can lower your hand because every time I look at it, it looks as if you are raising your hand. I'm not sure if you raised it again for the second time or still for. Oh, Jose, is it Jose or Jose? I don't know how to pronounce that. I hope. Yeah. You can answer Jose. I see your hand is up.
Okay, so I think a vector is a physical quantity with both magnitude and direction.
Thank you. That's very true. It's a physical quantity. I think I once told you guys how important vectors are. Because you mostly hear people saying, "Oh no, I'll never use physics in my life." That's very wrong. You will use physics more times than you can count, especially maths. Physics is an example of how you would use maths, by the way, in your life. And then physical quantities that has both magnitude. Remember, we said the magnitude of a vector is represented by, if you check a vector it's just an arrow, it's represented by the length of the body. So that's why I'll show you in this diagram. Hopefully they did what I want. Let me see, magnitude and direction. So that's why you find that vectors with different magnitudes seem to have different lengths. Let's check here. They probably did what I'm talking about. Yeah, you see this one. You have F being 250. Obviously, 250 newtons is bigger than 50 newtons. So even when you are drawing these vectors, the situation must represent those numbers. So you see that F is 250. So therefore, its vector must be longer than a vector representing 50 newtons, as you can see in this diagram. So they did very good here. It's just that for this one, I would have liked it if maybe they made it to be the same length as W, because these are both 50. Right. So yeah, T and W were supposed to be maybe the same length. Say T was supposed to be here. But nonetheless, these things are never drawn to scale. But the main point is whenever you draw your vectors, show us that you understand that the vectors lengths will differ because they have different magnitudes. If they have the same magnitude, it means the lengths will be equal. It's not that important in grade 11, but when you continue doing physics up to university and so on, it becomes important. It shows that you understand what you're doing. Okay, so because this thing of just learning to answer ends in high school, once you go to university, they don't care that you know how to answer. They want you to see if you actually understand what you're doing. The reason that's done is because you will become a doctor, you'll become a scientist and engineer. You don't want to go into society and then you are someone that's incapable of understanding even the very same thing that they're doing. You'll kill people. We don't need that. All right, so now they want us to calculate the horizontal components of forces T and F. Okay, so by horizontal components, remember what I said. It's either they'll say horizontal components or X components, right? It's the same thing, depends on which one you prefer. But it helps to know that those two words they mean the same thing, okay? So in this case, you just go to vector T, you find T, let's call it Tx. You go to vector F, you find Fx, right? So who wants to give it a try? Just tell me how we would find Fx, for instance. I want to see how much you guys understand with this one. So how would we find Fx? Fx being, remember, if this vector is like this, right? It'll have component in the y. This is F. This is our Fy, because it's in the y direction. Right? This will be Fx. I don't even have to add a comma. I can just say Fy. I usually add a comma if this maybe was F2, then I would say F2x or F2y. But in this case, there's no number, there's just F. Or there's no letter, it's just F. There's no other subscript. So you can just say Fx here. Okay, so you know what the drill. You just come here, you draw this line. Then you come here, you draw that line. Then you start at the tail of F. And the component must end where that line is. The head of the component must be there. So that will be Fy. Right, then you have the angle here, which is what? 60 degrees. So guys, how do we find Fx? This case, they want Fx. So they want Fx and Tx, but well, let's start with Fx. Who wants to give it a try? Let's see. You can also type for those ones, for those of you that are actually shy on unmuting. You are welcome to type. I'll give you a minute to think about it. I assume you have book there with you. You can just work it out on your book and see what you get. But I just want the expression or the equation. Then we can find the final answer together. Doesn't matter. We want Fx, after we'll find Tx. Give it a try. This is where I figure out your knowledge gaps. This is where I also meet you halfway and cover that knowledge gap so that you never, ever have that gap again. And then you can answer other physics questions confidently. So I really, really want you to try. Mm, 22. At 22, I will continue if no one wants to give it a try. And then if I see Luanje, You're saying we can say fx is equals to, oh, it disappeared. Let me just click. Fx is equals to cos 60. Okay, let's see. All right. Yes, that's true. That's very true. So, Landley is correct, but I'm not sure if all of you guys got the same thing. So let me just show you, if you remember how we get this, ne? We have fx, right? I mean f, sorry. It's f, and then it's going like that to even write it here. It's just that we usually prefer writing the letter or the label of that vector at the end. So it's just a thing. So now let me color code it. Our y component will be red, our x component will be, actually, this doesn't look nice. Our y component will be red, our x will be purple. So this is the tail. You don't have to draw these dots like me. It just helps me, I guess, make it look a bit more neater. And then we'll sketch our line from the head all the way back there, and then another one from the tail until these two lines meet, right? So that's where our y component will be. That's fy, okay? Say fy. And even write it here. It doesn't matter. Fy. You know that this whole vector is fy, okay? I know sometimes when I write it at the head, people get confused when I start doing the trig ratios. So I'm just trying to show you. It's like basically labeling a shape. If you have a square, if you add stuff, this is side A, this is side B, this is side C, this is side D. That's what we're doing now. Okay. So then let's do the X now. Draw a line from there, and then another one from the tail to where this vertical line is. So that's where our X component will end. That's the head will be placed there, but it will always start at the tail. Tail of what? Of the 2D vector. Remember, we are just decomposing a 2D vector. Why do we always find components for a 2D vector? So that it's easy to add things together. Because if you check here, it's not very easy to add vector F and vector T together. The reason for that is because they are on different coordinates, basically. But once we find their components, like we know that now they will be aligned. You'll have an fx here, and then you'll have a tx here. So now you see, these are on the same axis now. It's easy to add stuff that are on the same axis, right? And then their y components as well will be on the same axis, which is the y-axis. So that's why we always decompose vectors. Is it decompose? Yeah. We always find there's this word I'm looking for that you guys are familiar with. We always resolve vectors. Yes, that's the word I was looking for. Okay. Then we put our angle here, 60. I'm just trying to show you how one leg got that cos 60. Right, so the purple one we said is our fx. So now what happens here is, remember, this is just a right angle triangle. This. I usually draw it where the angle is as well, so that it's easier. I don't have to. What I mean by that is you can either draw it where I'm drawing it now, or you can use the other triangle, this one. Depends on where your angle is located. By angle, I am talking about that 60, right? It's the angle of your 2D vector, or the direction of your 2D vector. So, but anyways, you'll always get these two triangles. You choose the one where your angle is, but you don't always have to. You can always choose the other one, right? I just prefer the one where the angle is because it's convenient for me. Okay. So if you check, that's a right angle triangle. Now, from here onwards, it's just the maths. How do we find the side adjacent to the right angle triangle? We used cos in this case. Cos 60 is equals to adjacent over hypotenuse, which is our hypotenuse is f. That's it. Right. And then how do we find the opposite side? We use sine. Sine 60 is simply Fy over F. Opposite over hypotenuse. So that's how Longley found cos 60, which is this one. So we take that, we say obviously cos 60 is Fx over F, and then you cross multiply because this is over 1, right? You cross multiply, and then what you get is Fx is simply F cos 60. Then from here you can substitute. We are given that F is what? 250 newtons. So 250, I usually like using brackets because they group everything nicely and neat. Cos 60, right? And then, where's my calculator? 250 cos 60 should be 125, I think. 250 is 125 newtons or newtons, you know, if you want to be that guy. So now, that's what we have, okay? So I hope you guys got this part. For every other component or every other vector resolution that you must do, this is the step that you always follow. Of course, with practice, you don't even have to draw these triangles that I'm drawing here. You can look at it, give it one look, and then you can just tell that it's going to be F cos 60, F sine 60, whatever, right? But while you are still practicing, of course, when you're still starting, you will have to keep doing these steps until your brain is sort of used to the methodology. After that, it can do it faster. You don't even have to write these steps down. Because the reason you have to practice, this has no marks. You'll just write it on your separate, what's this, calculation or rough work paper. They only start marking from here. That's where they start marking, okay? This will not give you any marks. They assume you know that from maths. Even in maths, you don't get marks for this. So now, let's find the horizontal component of t now. So that's tx. Okay, we'll move a bit faster now because you should have seen how to find fx, fy. The same applies to t. Right, so let's move. What is tx? Please answer. And by the way, if you know these vectors, you've already covered some grade 12 work there. So, but let me see. Yes. So yeah, in grade 12, you'll also use the knowledge of your vectors. Most of the work that you have in grade 11 will be in grade 12, as is. Nothing will change. Then they'll just add a few things. So if you master it here, you are set for grade 12 as well. You'll just be revising. All right, so what are you guys getting for TX? You do the same thing. Resolve, you find the trig ratios, then you proceed with your final answer. So my fx was this one. This expression is what you would call your fx. It means my fy, for instance. Let me make it red so that you guys can sort of follow through. Okay, it means my fy, if I cross multiply, would be f sine 60 degrees. Okay. All right. So the answer, or Lanley is asking, is the answer not 25 newtons? Let's see. It would be 25 if F was 50 newtons, but F is 250. So that's why it's 125 instead of 25. Okay. Yeah. I hope you understand. If you don't, you can still ask. Yeah, just check there. You might have made a mistake and missed the 2 and put a 50 instead. Okay. Give me my answer, guys. I want my answer. Oh, you're saying for T. For T. Okay, let's check. For T, TX. So let's draw TX. I mean T actually. So T will be like this. Like I said, when you are still starting, you must draw everything. It saves your brain. Remember, your brain likes habits, okay? Structure things so that it knows what logic or code is like. It's following an algorithm. So the more you practice that algorithm, and hopefully your algorithm is correct, the better you become at that problem solving topic or whatever topic you're solving for. So just remember, guys, that's why practice is important. So the more you practice, it becomes a habitual thing. The more habitual it is, the less brain power you will use, because things are just happening automatically now. All right, so we have 30. These are just free study tips, guys. And they work, by the way. I'm not just blabbering here. You must try them out. You must be efficient. And then let me use my color coding, my TY. Oh, this pen is misbehaving now. It's fine, guys. You can see this is TY. Ne? TY. Let's do TX. From here, this is my TX. So, I see that you made a mistake. Okay, that's fine. Mistakes are fine. Don't worry about that. As long as you see your mistake. That's what I want, guys. If you are able to self-diagnose or troubleshoot, you are fine. Because if you can't do that, it means you still need to practice just a little bit more. So, this is T, sorry. Then now from here, I can say T. Let's do our triangle thing. I'm taking it step by step. If you still don't understand after this lesson, it just means you need to practice. It's no longer that you don't get the concept, okay? Sometimes all you need is practice, which is where most people miss it, by the way. So here's what happens. When you're in class, your mind will force you into believing that you get it. But understanding something doesn't mean you can apply it. Right? It's understanding and applying are different things. So once you understand, if you don't practice, you will forget. And when you forget, you are starting from scratch again. So when you see that thing again, it's as if you had never seen it before. That's how your brain works. So I think there was people who studied that and they say, well, you forget about 70% of the information that you don't use in the first 48 hours. So yeah, that's why you keep forgetting and you think, oh, you can only remember songs but not schoolwork. It's because you sing those songs repeatedly, but you don't do schoolwork repeatedly. That's why I keep forgetting. That's all there is to it. Oh, now. All right, so we're finding TX. So we will say cos 30 is simply TX over T, right? Then we cross multiply. Therefore, TX is simply T cos 30 or 30. Right, so that's what we find, you know? And then from here, we can substitute our value. Our value is, we said T is 50 and 50 cos 30 degrees. My degrees sometimes looks big and it looks like a 300, but don't worry, it's 30 degrees, ne? 50 cos 30, that is 43.30. There's no such thing as 43.30, guys. There's 43.30. The numbers after a comma, you don't call them like you'd call the first numbers before the comma. I'm teaching you here. So yeah, it's just etiquette though. It's fine. If you call it 43.30, that's still fine. So now that's it, ne? That's how you'd find TX. So I write it, we can continue. So basically we have solved for these 2 marks. Do you see what I meant when I say all these other steps will not give you marks? Because they will just come and mark this. Actually, they won't even mark this. They'll make you answer. Because the answer is what's important here. So what they will do, they'll just come and mark that and mark that because it's 2 marks. So all of the diagrams and cross multiplying and what, you practice enough, you'll just do it in your head and just give them the equation answer, equation substitution answer. Okay. All right. So that is that. So let's go to 2.2.2. If you have a question, please, guys, you stop me, you ask. I do not bite people that ask me questions, school-related questions. All right. So 2.2.2. For T, you can even divide it if you want. For T, they want now vertical components. We just did horizontal, so now let's do the vertical ones. So for T, you would say T Y is T. We said it's T what? Ty. If Tx is cos, Ty should be sine. But you know that why? Because you can just say sine 30 and you get that it's Ty over T. So then you can cross multiply, okay? So that's T sine 30. I think this is where you would get 25, right? So this is where you'd say 50 sine 30 degrees, and then you would get 25 newtons. Good. Aha. Right, so that's how you'd find Ty. For Fy, we already had an expression for Fy here. So we can just take that and bring it down here as well. Oh, we ran out of space. Let's see. I was hoping to fit everything here. Let's see if I can move this. Yeah. Proper. No. You are not watching it. For F, we are finding the vertical. Vertical is up or down, which is the y-axis. Vertical, this is how you would find it. So we use 125 times sine 60. So 125 sine 60. I get 108.25 Newton.
Sir,
Yes.
where does that 125 come from? Because on the other time, it was 250.
Oh, thanks. My mistake. Yo, I don't know why I took 125. That's a weird mistake right there. Okay, so I'm glad that you guys are paying attention. Lovely. That's good. So yeah, it's not gonna be 108. It's gonna be what? Let's see, 250. Probably gonna be twice this. Sine 60. It is 216.50 or 51. So that is twice what we got initial to 16.51 newtons. Newton. By the way, Isaac Newton, guys, discovered more than just the Newton's laws. He also, I think he discovered calculus, which is another branch of mathematics. So he was a great scientist. I think he was doing his research and he realized there are certain things he couldn't solve for because something was missing in maths. So he stopped his physics there and just did a side quest to develop maths that would help him solve his physics problems. And that's how calculus was born, I think. So, yes, that's just a fun fact. Or hopefully my facts are not wrong. But if I remember correctly, that's what happened. You can check for yourself though. Now, that's what we have. Okay. So let's check 2.3. If we're all happy, we can just move to 2.3. So before we move to 2.3, can we find the x component for the w vector? This vector given in this problem here. Does w have an x component? And if let's say they were to say, give the x and y components of the vector w, this one, what would you say? What would you say is fx? And what would you say is fy? Just as this is me being curious. I want to see how you guys think about it. So please just give it a try. I'll give you 1 minute. So at 43, if you haven't answered, I'll give you the answer. Okay. Silo and Lace is typing. Oh, okay. The W. What about FY? Why are you guys scared of answering? I keep getting answers from the same person. I usually don't like that one because I don't know if everyone else is, if we're on the same page with everyone else. In other words, I don't like it if anyone is being left behind without me knowing, right? Because I don't want anyone to be left behind. That's the whole point of it, of a tutor. You shouldn't see me as the same way you see your teacher. If you are scared to ask in class, when it's a tutor who's in front of you, you should not be scared. Everything that you are scared to do in class, like asking, answering, even if your answers are wrong, all those things, no one will laugh at you here. I don't think anyone knows you here, right? You guys are from different schools. No one can see your face. So I don't understand why you guys would be scared. Okay. Okay. So basically, okay, I see. Oh, for your first answer, when you said x will be 0 newtons for w, that's true. The reason it's 0 newtons is because w is a 1D vector. It's only along the y-axis. It's all going along the y-axis. So it doesn't have x components. So therefore, fx for w will be 0 newtons. Right? Then fy will just be 50. It's basically the vector itself. You can call it an fy. No, not fy, guys. Sorry. Maybe that's why I'm confused. I meant wx and wy. Sorry. If that was confusing, that was just a mistake there. So wx will be 0 newtons, while wy will be 50 newtons. It's basically w, the actual vector w, because it's only along the y-axis. So if you were to be asked to write w in its components and find the wx and wy, this is what you would do. Okay. So yes, normally we don't give directions for components. We only give directions for the vectors themselves. So yeah, that's why even here, after finding, even though the component is a sort of a vector, we didn't write a direction basically. We only care about the direction of the actual vector itself. So in case you were wondering. And then, okay, I guess we're all happy. Let's go to 2.3 now. So we're asked to determine the magnitude and direction of the resultant horizontal force. Resultant horizontal force. Oh, yes, I see. And then 2.4, we're asked to determine the magnitude and direction of the resultant vertical force. Okay. So one thing I can see here, it makes sense why they would do this in a test, but in an exam, whatever, you see this question from 2.2 to 2.5, this was going to be one question worth about 7 to 9 marks. So in this test, this was a test past paper. I think I took it from Eastern Cape. Oh, another thing, if you want these, you are welcome to ask on the group. I will always send you links to where I find the papers and so on. But alternatively, you can just go to Google and search past papers, grade 11, physics, paper 1, whatever. And then you can find all past papers that you want. If they're published online. If they're not, then you won't find them. All right, so magnitude of and direction of the resultant horizontal force. This is something I once said on our last lesson, if you remember. I said, whenever we sum the step that we actually did, let me see if I can find it. You see this? Yes, this. If you guys remember this, if you're not there, let me just go to find. Aha, this step. Step 4 and step 5 or step 3. Sum of the horizontal components of the vectors that are in that diagram. So in our case, we would sum all the horizontal components of T, F, and W. That resultant sum, that sum is your resultant in the Y. But it's not final result, that's a component of the final resultant. So that's why we do Y. See this diagram. The resultant itself, it has a component X and RY. We call them resultant X and resultant Y. So when we combine resultant X and resultant Y, that's how we find resultant, the overall resultant. Right, so that's what they're asking in that question. They're asking us to find RY in 2.4, 2.3, and then RX in 2.4, I think, but we'll go back and check. Right, that's what they're asking, those vectors. So it goes to what I was saying. So the reason we have to resolve vectors to their components is so that we can find this RY, find this RX, and then by finding RY and RX, we can then now find the overall resultant of all those vectors that are involved. I was muted, guys, and I had spoken for such a long time. So, yeah, I think you can hear me now. So what I was saying is, what's the thing? Yes, I think I've said a lot, but let's go and do it. So we are going back to 2.3. So 2.3 is saying, let's find the magnitude and direction of the resultant horizontal force, right? So basically, we are finding horizontal, sorry, is Ry, and no, horizontal is Rx, sorry, and vertical is Ry. So that Ry, Rx that you've been seeing, it just means resultant along the X and resultant along the Y. Resultant along the X being, we add all vectors that are acting along the X direction. Resultant along the Y means we add all vectors that are acting along the Y axis. Okay, so that's what it means. That's what it basically means. Let's see. So we can even combine this to one question, but it's fine. Let's do 2.3. Remember, whenever you add vectors, you must choose a direction, okay? Always choose a direction. So for the X, for instance, I always choose the simple one. I know that in my X-axis, let me remove this. Okay, it's fine. So I know that in my X and Y axis, always think about it in a Cartesian plane. You'll never go wrong. You have the Y-axis, so you have the X-axis, and you know that anything this side of the X-axis is positive. Anything that side of the Y-axis is positive. Anything this side of the Y-axis is negative. And anything that side of the X-axis is also negative. So whenever I choose directions, I just choose my positives, the directions that I regard as positives. My positive Y and my positive X. What do I mean by that? So I'll say I choose upwards as positive because I know Y is positive when you go upwards, from the neutral, from 0. And I'll choose to the left as positive because I know my X is positive when I go to the left. No, not left, sorry, right. My bad. I keep making mistakes today. Sorry, guys. I don't know what's happening. So now, yeah, that's what I mean. So I just choose the ones I know that if you go to a Cartesian plane, you will also find it like this. So even when I'm on my maths and physics, I can sort of link the two with ease, right? It's just convenient for me. But you can choose left, you can choose down as positive. It's up to you. But once you choose a direction, you stick to it. You do not change it. We don't do changing here. If you change, you are doing, I don't know, some physics for aliens, not us. Now, so we are doing Rx for 2.3. So what does it mean? It means we choose the directions. Remember what I said? You can either write it in words, like saying upwards is positive, or you can use a symbol, like what I like to do. In this case, we are in the X, so I'll say right is positive because I'm avoiding writing English, okay? I don't like too much English from physics. So we can then say now sum of Rx is Fx plus Tx. Remember, we chose a direction. So Tx, if you remember very well, let's go back here. Tx, right? If I resolve T into its vectors, I will have Ty going there, and then I'll have Tx. Oh, what is this pen doing now? Going? Oh, Ty is too long. Should be up until here. That's my Ty. And I'll have tx. Tx is a bit shorter, should be here. So I'll have these two. Now, let's do the same for f. Let's use a different color for f. We'll have f. Okay. We'll have fx going there, right? And then we'll have fy. Fy is longer than ty going there. Right. Now check. When we are summing, we chose to the right as positive. Ne? That means our fx in the sum will be positive. Anything opposite to fx or anything opposite to the direction that we regard as positive, that thing is negative. Right? So if you are happy that, I don't know, you passed grade 11, anyone that is not happy for you is negative, okay? It's the same with these vectors. So tx is negative. Why is it disagreeing with us? Because we said we are going to the positive. Why is it going there? Why is it going this way? So it is negative. So it's a fake friend if you know fake friends, right? So let's go here and write it. So when you are summing here, what does that mean? It means you come here and you put it as negative. Okay? So sometimes if you are used to practicing, you can just say fx minus tx. So I usually put all the steps so that you know where does the minus come from. Why is it not a plus? It's because it's opposite to the direction we regard as positive. Okay, so it's that fake friend you must be aware of. Okay, why are they opposing good things? Now, we said fx is 125. Tx is, what's tx? Oh, 25 is it tx or ty? Oh, tx is 43.30, sorry. If this constant scrolling is messing up with your mind, as I'm very sorry. There's no easier way of scrolling here. I have to just do it like that. So we have 125, okay. Let me use my calculator. Minus 43.30. That is 81.7. I know you guys will check my answer to confirm if it's correct. Okay, so check this. Remember, they said we must also specify the direction. Eh? So since our answer is positive, it means our vector is going to the right, which is the direction we chose as positive. And remember, if our answer was negative, since we chose right as positive, it would mean our vector or our resultant x vector is going to the left instead. You remember that rule, eh? So this one, we would say right or east. I assume since they gave us this whole cardinal or compass, let's use these directions. Oh, even in the problem, yes, north, east, southwest, yeah. Let's use north, east, southwest as our directions. It's even stipulated there in the problem. Ne? So my rule of thumb is, if in the problem, even if sometimes they don't tell you to use north, east, south, if when they're introducing the problem to you, if they say vector A is going to the north, vector B is going to the south, it means you must use those type of keywords to describe your direction, right? Even if they don't tell you to use them, but you must stick to them. You don't invent your own directions. Okay, just be very careful with that one because it's easy to miss it. Okay, we are happy with this one. Okay, so let's go to 2.4. They want RY in 2.4. We read it with you. I choose up as positive. Remember why I choose up as positive? It's just convenient to me. You can choose down. It's up to you. So this thing is just a summation. It's not an E, guys. I'm just writing it in a horrible way. Let me try the right way. Yeah. Sigma means sum. Let me try it here as well. Yes. RY. Okay. We will say FY plus TY. But remember, there's another vector, W. And W is along the y-axis. plus W. So what is happening? Because we are adding everything along Y and everything along X. So we do not discriminate. Okay. Some vectors are already 1D. We turn them into components when we start adding components. So if that vector only lies along the X, it means when I'm adding X components, I will add that vector there as an X component. If it lies along the Y, like in the case of W here, whenever I'm adding all the Y components, I will add this vector as well. You don't exclude it, right? Because remember what we said, the reason we resolve vectors is so that all vectors are either in the Y and or in the X, or in the Y and in the X direction, so that it's easy to add them together so we can find the final resultant at the end. Okay, that's why. So we do not neglect any of them. Now we have W, but check, both Fy and Ty are going up, which is the direction we chose as positive. And only W is going down. That means W will be negative, right? We don't like W. Y is opposing. W is like friction. If you guys have reached the topic of friction, is opposing the direction with we are going. Okay, in this case, we're not going anywhere, but we just chose up as positive. So Fy is, what is Fy? 216.51. Ty is 25. Okay, 216 point, yo, my 216 is weird. 216.51 plus Ty is 25 minus 50. Aha. Let me punch my calculator here. You guys should give me answers. I shouldn't punch calculators when you are here. Minus 50. I get 191.51. You can confirm on your side. 0.51 newtons. Now, it's positive. It means it's going north. Okay. So that's what happens. That is what happens. The concept of vectors is very full. So you must master vectors. I think I once told you guys a story of how vectors are also used in when people or engineers that design beams, see those beams that are like this, even bridges actually. Say you have, yeah, even a bridge. Those forces are analyzed as vectors. Those forces acting on the bridge's support structures, like the links, the cables, and everything. In fact, even calculating the amount, not even the amount, the size of the cable that we need for that bridge, we would use a vector. We would use vectors when sizing those cables and so on and so forth, right? If we were civil engineers, if we were design engineers, and so on and so forth. So it goes on and on, really. And that's it. Like, there's a beam. If in your house you've seen this, I forgot how it looks like, but yeah, something like this. I don't see it in my house right now because yeah, but you guys know what I'm talking about. It's on the roof, this thing. Yeah, they designed that using in their calculations they take into account vectors. Oh, vectors. Because those are forces, right? And forces are vectors. Okay, so let's finish for this question. It has taken too long. So now we have 2.5. Calculate the resultant force of all the forces acting on the object. You see? Now we can find the resultant force. If you remember what I said earlier, this question would be a 9-mark or 7-mark question in a typical exam. but they just broke it down for you. Remember when we did it here? Let me see if I can find it. Yeah, this one. You see this one? We once did this question. So you see this question, they just said magnitude and direction of the resultant of all these three forces, right? And then we did all these steps that we just did now. But in this question, they didn't break it down for us. They were not so kind. When they break it down for you, you have much more fighting chance if you don't know the concept very well. When they don't break it down for you, it's either you know or you don't know, okay? So essentially, that's what I mean. So all these steps that we did here, that I taught you guys, you resolve, you write down the components, you come and you sum vertical, you sum the horizontal, step 4. Then now you find the resultant using Pythagoras. Then you find the direction. That's everything we just did again. So when I say vectors don't really get complicated, it just depends on who's setting them. That's what I mean, right? Typically in grade 11, the maximum number of vectors you will get is 3. And then they will ask you to find the resultant. So if you practice enough questions, you'll be able to effortlessly and confidently get a total for all these questions, okay? I hope after this lesson, you'll be confident that whenever you see vectors, you'll just get a total. It doesn't get too complex than this, guys, I promise you. You just maybe, you don't believe me, but once you practice more, you will realize that this is like ABCs in, I don't know, preschool, okay? So now, yeah, let's find FRS. Usually, because at this point, what we have is we have RY and RX. And remember what we said, we can say we have a triangle like this now currently. And luckily, we have RX and we have RY. And we're looking for FRS. Okay, guys, I'm back again. As annoying as the network is, but we have to persevere. Weird. So, yeah. So we have that. And now we can plug in our values. So we got Rx. Once you can find the components, guys, everything else is just standard. It's procedural. By procedural, I mean even if you were to come back 100 years from now, you would still follow the same procedure or the same steps. It doesn't change. Even your uncle that did matric or grade 11 in 1982, they were resolving vectors like this. Okay, in 1982, black people didn't get that kind of education, but you get my point. Right, so 81.7 and then 191.51. And then, yeah. Temba, I see your hand is up. You can ask. Hello, Temba. Unless you made a mistake and just click there. But if you are talking, your mic is muted. so we can't hear you. And then if you made a mistake and you click the icon, I'll just continue. Let me give you a chance to ask them. Temba, you can ask. Yeah, I think maybe he's having trouble with network because I see he just logged out. Okay, guys, so this will be root 81.7 squared plus 191.51. You just join us soon. So this is 208.21 newtons. So one thing you will notice about the resultant vector, it's always a number or a magnitude greater than both of its components. Okay, if you get, let's say you were calculating here and you got something like 60, notice that 60 is lower than both these guys, then you would have to retake your steps because likely it means you might have done a mistake somewhere. There are a few instances where this would happen, right? So if you get a value bigger than both of them, you know that, okay, there's a higher chance that you are correct. The reason I'm telling you this is because physics, maths, or whatever, any subjects that requires calculations, you can sort of gauge the correctness of your answer by using simple logic.
Yes, sir.
You know that the resultant is a combination of both its components.
My
Yes,
network
Jimmy.
today is giving me problem. I have missed a lot of content of what you did today.
Okay.
Yeah, so every
So,
time when I try to join the meeting, my network just keeps on disconnecting. Even now, it is only counting from 5. It's going to disconnect. So I want to check if this lesson is being recorded now.
yes, sir, we are recording this lesson. So, yeah, I will send you guys the link. It's just that sometimes I get so busy, I forget to upload it on YouTube. But if you guys remind me on the group, it's not that I don't want to share the lessons, it's just that I forget, okay? These are all your lessons, guys. Even the notes, if you want them, they are all yours, okay? Just remind me, because sometimes things get a bit hectic. But yeah, it's being recorded, and whoever needs it will get it. I'll just share it on the group.
Okay, sir. I'll catch you up on Friday. Yes, it is disconnecting.
No stress, no stress. Let's continue. This looks ugly. Let me change it. Okay, it just got worse. Let's do this. Sorry, guys. You just have to think this line is straight. It's fine. Now, that's the magnitude. But we need to find direction. Let's find direction. I don't want to go to a new page. What's happening? So I don't want to go to a new page. I'll just write here. Remember, with the direction, nothing really changes. You just do this. Excuse me. You'll say tan theta. It's simply ry over rx. That's the direction. And then you know that theta is simply tan ry over rx. Not tan, I mean arctan or inverse tangent. Arctan. If you continue with maths, you will notice that you will stop writing it like this and start writing it like that. They will tell you to stop writing as tan. If you want to, Okay. So now tan minus 1. But for grade 11, it's all fine, right? Unless you want to 87. So that will 67 degrees. I actually got, if I show you, it is 66.895. Okay. 8, 9. Oh yeah, no, this is wrong. So let me round off. This is 66.90 degrees because you round off. All right. So if it was, let's say 66.99, maybe 6 or 5, whatever, this will just be 67 degrees. Because if you round off the whole thing, it's just 67. If you remember how to round off, okay? So now we can write our final answer. Therefore, our complete answer, the resultant force with its direction is 208 or 208.21 newtons, and then the direction is 66.9 degrees. So that's how you find the final answer. Yo, my pen is betraying me today, guys. It's traitorous. It's a traitorous pen. But anyways, this is your answer. Okay, so that's what we have. Okay, that's all there is to vectors, guys. Then for this first part at least, then now what you also get is when you have now what's this, equilibrium conditions to consider. I think someone asked me about equilibrium conditions. I couldn't find another example, unfortunately, but give me a second. Let me see if I can find one example about it. I couldn't find one before our class. Just give me a second. See. Okay, I can't find something. Let me see something here. We once did an equilibrium question. Gotcha. Weird. Okay. Mhm. Okay, guys, I'm struggling to find that example. There was an example on equilibrium you once did. Wait, is it this one? Oh yeah, it's this one. So does anyone still need me to explain how this whole equilibrium thing works? Because there's just two parts to vectors. There's the equilibrium part, then there's the part where you just do, the everything we just did now, where you have all the 5 steps. 1, you identify components, you resolve them, you add the Rx, you add the Ry, you find you find the resultant and you find its angle or its direction. Then there's the other part where there's equilibrium, and you have to solve for something usually. So sometimes they'll say solve for M, mass. Sometimes they'll say solve for tension. Usually you have to solve for something though, but you have to first recognize that it's equilibrium. Okay, so does anyone still need help with that? We can just explain it using this example, I think. But yeah, just if no one needs that, we are fine. That was it for today's lesson. In fact, it was not a lesson. It was supposed to be your, if I can call it, Q&A, where you are asking me questions and then I'm answering everything that you are still unsure about. So if you remember, I said send me questions that you struggle with. Or you guys didn't send any, so I don't know, maybe you're fine there. And then yeah, but this session was just for that. That's why I didn't bring many examples. Because I don't know what you guys are struggling with basically, except the things that you told me in the group about. Even then, I don't know if any of those people that said are struggling with the vectors, if all of them are here, or if none of them is here, I don't know. So now, here's the thing. Just tell me, do you guys still need the equilibrium explanation, or we are fine with that? Or if you have a specific question, you can still send it on the group, and we'll do it now, fast. Yeah, you just have that luxury for now. And or we can do it on, because I think we still have a lesson on, is it Friday or Saturday? Yes. Tomorrow is Thursday. Yeah, we have a lesson on Friday. So you can either do it then or do it now. It's up to you. Or do now and do more questions on Friday. All right, guys, what is it? Let's see. See, some of you are sending questions here. Hmm. Guys, why are you silent? Oh, Lou. Okay, guys, so I assume you guys are fine then. If you still have questions, remember we can add them on the group. Yeah, just add them on the group. Or if you are scared of sharing them on the group, you can send them to me privately, and then I'll share them on the group so everyone can see it. But no one will know they're from you, obviously, because I'll be the one who's forwarded them or somewhere, in case you are scared of that. And then we'll figure out a session where we just go through them. And then, yeah. But other than that, I think this is it for today's session. And yeah, you guys can go ahead and log off. We will catch up on Friday. Kina